Okay, problem number 26 on page 563 says x squared minus 14x plus 49 is equal to 64. Now, I could move the 64 to the other side and try to factor it, but that's not what they want me to do in this section. They want me to solve it by using square roots. And some of these might not have a solution. So if you end up with the square root of something negative, you know that's a no solution problem if you ever see something like that. So here's what they want me to do here. This is kind of weird. They want you to rewrite this as a perfect square. So you kind of are factoring this side over here. Wouldn't this side over here, if I factored it, what would multiply? I could come over here and do my little, you know, yeah, it's going to be x minus 7 squared. If you don't see that, look at it this way. I'm going to multiply to get that positive 49, and I'm going to add to get negative 14. Well, wouldn't negative 7 times negative 7 multiply to give you a positive 49 and add to give you a negative 14, right? So couldn't I rewrite this as x minus 7 times x minus 7 is equal to 64? And that is x minus 7 squared equals 64. Remember how sometimes they would write it that way? They were kind of teasing you for this section. So on problems in section B, you're going to try to factor. I'm going to put section B. You might want to write this down as a reminder. You're going to try to factor one side into a perfect square. And then you're going to go about your business like before. You're going to square root. I'll just put square root. Because if I can get the left side written as a perfect square, now can't I just come on in and to solve this? Couldn't I just square root both sides? And now that becomes like the problem we just worked, doesn't it? Like number 21. Because what's the square root of something squared? Evan, what would be the square root of x minus 7 squared?
That would be...
So the square root of x minus 7 squared is just x minus 7. And what do I need to do on the square root of 64? What is the square root of 64? A. And I need a plus and I need a minus, right? So these problems in section B are just, you have to do a little bit more work to get them to look like the section A problems. So I have two equations to solve, don't I? I have x minus 7 is positive 8, and I have x minus 7 is negative 8. Do you think this is going to work on just any old problem that you pop out in front of your face that you make up? No. It's only going to work if what they've put on the left side will factor into a perfect square. The section we're skipping is how can we make any old thing look like a perfect square. But I think we should skip it because it's kind of harder for, usually students in Algebra 2 struggle with it a little bit, and I just don't think it's a good developmental time for you guys to learn that yet. Some of you could just fine, but some of you, you're still like, factoring is still kind of getting settled in your head, so I don't want to add too much. All I got to do once I separate it is just solve for x. I could add 7 to each side, and I'd get a solution of x equal what? 15. And then on the other side, if I add 7, negative 1. There's my two answers. If I plug those in, both sides will be equal. What is going on there? That's not even something that's got a, like, I don't even have a middle term to factor there, do I? So what are we always trying to do? If I can't factor that into some expression where it's like some perfect square on the left-hand side, what would be my backup choice to do here, you think? What am I always trying to get by itself? The square. Let's get the square by itself. Let's circle r squared here. Let's get that r squared by itself. What should I do? If I'm solving, I do PEMDAS backwards. Am I going to add and subtract first, or am I going to get rid of that 1/5 first?
Add and subtract.
Yeah, we always think if we're doing PEMDAS backwards, right second row. If I do PEMDAS backwards, I'm going to add 2 to each side. Now, when I add 2 to the other side, don't I really need to get a common denominator because I'm going to be adding a fraction and a whole number over there? What would 2 be with a denominator of 6? 12 over 6, right? Wouldn't this be, I could have written this as plus 12 over 6 if I wanted to write it with a common denominator right off the bat. I could do that. And you just thought fractions were in your past, right? 1/5 r squared. Now, what would 5 over 6 plus 12 over 6 be? 17 over 6, okay? Oh, this is not going to be nice at all. Y'all aren't going to like this one. Okay, I want to get the r squared by itself, right? How am I going to get the 1/5 away from it? I could divide both sides by 1/5, but that sure is ugly. Yeah, multiply by the reciprocal. Remember that from long ago? You can get rid of a fraction. Instead of dividing by 1/5, we can multiply by the reciprocal. Okay, so that gives me r squared is, yeah, 85 over 6. That's a lovely number. Now what do? I got a square equals something. How do I get rid of a square? Square root it. Just math rules over and over and over and over till we're sick of them probably, right? But you see how at least you always know, do the opposite thing, and the opposite of squaring is square rooting. So r is equal to plus or minus the square root of 85. Now I'm going to write it this way. Because in math, do you remember that it's a no-no to leave a radical in the denominator? The math police come hunt you down if you ever do it on your homework. Watch out. Don't go to sleep at night. The math police will be out there waiting for you. Do you remember how to get rid of that radical? I know, it is a little stalkerish, isn't it? How can I get rid of a radical in the denominator? Does anybody remember this? and say you don't have to do your math homework. Is that what it is because you were in jail? If I want to get rid of a radical in the denominator, do y'all remember doing anything called rationalizing the denominator? I can't remember what we did last year. I slept since then. So if we didn't do it last year, we're going to get to do it now. Yay. If I want to get rid of a square root of 6, wouldn't I need another square root of 6 to get rid of the radical, right? Because what's the square root of 6 times 6? Square root of 6. The square root of 36 is 6, right? Did that get rid of the radical in the denominator? Yes, that makes the math police very happy. But if I do something to the bottom of a fraction, I got to do the same thing to the top to keep it equal. So I also have to multiply the top by the square root of 6. Now, they don't care what the top looks like as long as the bottom's not a radical. So I've got the square root of 85 times the square root of 6. Well, what you do with that is you're going to combine them and see if you can reduce them. When you have two things multiplied under a radical, you got two radicals, and they're both square roots. I'm going to keep the plus or minus on this, and then I'm going to go ahead and multiply them under the radical. It's going to be 85 times 6. All right, here we go. This part's just reducing radicals right here. Now, 85 times 6, one thing I can do is maybe I could do a factor tree. I could put these numbers together before I see if they'll go, if there's anything I can reduce. But if I put them together, I want to have to turn right around and kind of split them up into little pieces. So sometimes what we do is we just leave it like 85 times 6. Isn't 85, wasn't that 17 times 5? And those were prime numbers, right? What about 6? What were its prime factors? 2. If you did a factor tree, it'd be 2 times 3. All that over 6. Under that radical, do you see any matching numbers where I could get a square root out? Because remember, a square root is 2 of a kind. Are there any matching factors under that radical? Not 2 of anything, are there? So what that tells me is this top radical, it's not going to reduce at all. So how I'm going to write my answer is to put plus or minus, and then if I multiply 85 by 6 now, I'm going to get 510. You would think there'd be something you can get out of that, but there's just not, over 6, which you can't hardly read. But that's the answer, plus or minus square root of 510 over 6. The 6 is just there. I just can't get it fit on the iPad completely.